This video will continue our discussion of working with oblique triangles with the new section called Law of Cosines. I'm going to give you the setup here, and I'm going to I challenge you to take that picture and maybe work onto the right and see if you can come up with the formula that's here at the bottom. You know what you're aiming for, so I would like you to maybe try it. This is a common practice in upper math, left to the reader. So I'm not going to show you how the formula comes about. I'm never going to ask you to do that. So if you can't get to it, that's fine. But I challenge you, and it's going to help you like prepare for the final and stuff like that because there's a lot of trig work involved. Now here are formulas. These are a little more involved than the law of sines, but it's really not bad. You can actually memorize these pretty easily. Notice that this part right here alone is just our Pythagorean theorem. If you actually let alpha be 90 degrees, this cosine of 90 is 0, which means it just marks that out, leaving me with Pythagorean theorem. So I want you to notice a couple things that may help you memorize. So I'm trying to find A. Let me get a smaller one here. Trying to do A, trying to find that, right? So the Pythagorean theorem includes the other two, B and C. Then you have to memorize the worst part of this is minus 2. Minus 2, those same variables, times. Right? Times 2 BC, so it's the two variables, and then it's cosine of the angle corresponding to this side. So take a look at the other two. They're not too hard to memorize because of the Pythagorean part. Again, my opinion on formulas is to be familiar. You don't need to know them exactly. Memorized. Some teachers disagree with that. I think you should be familiar. That way you know it exists, and then you can use your phone, use whatever in the future to look stuff up. Right? Okay. So let's do an example. Now, in the last section, I talked about making this like chart. So I'm going to make it again because I really feel like it's helpful, especially once I start giving you problems or like on an exam and you got to figure out which one do you use, sines or cosines, or do you have to at all? Okay, so A, B, and C. And I'm going to write down what they gave me, 30 degrees. And then they gave me little b and little c. Okay, I want you to notice here, we cannot use law of sines. The reason we can't use law of sines is I need two of them together. All right, and here we don't have that. I have these two without the A, I have these two without beta, and these two without gamma. So I can't use law of sines. All right, to practice, I'm going to write down my formula. I'm looking for little a, so little a squared is equal to b squared plus c squared. That's the Pythagorean. And then minus 2, those two, bc, and then it's law of cosine, so cosine of alpha. We're just going to plug it in. So or a squared equals 12 squared. So it's 144 plus 24 squared. I'm going to plug in my calculator because I don't know that one. 2 times 144 times 24 times cosine of 30 degrees. So you can plug this part in your calculator straight up. All right, so I'm gonna clear it. It's getting a little messy for me. So 144 plus 24 squared minus 2 times 144 times 24 times cosine of 30. So I got this crazy big negative number. So somewhere in here is messed up. What did I plug in wrong? Oh, I plugged in 144. That should be a 12. That was the problem. I shouldn't have done the 144. There we go. 12 squared. So that's just a 12. Oof, okay, so I think I can copy and paste and just go through and delete the 144. Some of you guys probably caught that already. So we get two, there we go, 221.1693674,202. All right, and then I'm just gonna use the calculator here to figure out the square root. So A is about 14 point, and A, we're solving the triangle, so I'm going to do one decimal for my sides. 14.9. Okay, and then unfortunately, with these problems, you're going to do law of cosines once, and then typically after that, you have to do law of sines. So sine of 30 degrees over 14.9. So that's why we can use it now, is because I have alpha and little a. I have a corresponding angle and side. Let's go after beta. So sine of beta over 12. All right, so if I cross multiply and take the inverse sine, I get beta is inverse sine of 12 times sine of 30 degrees. All I did was solve and then take the inverse sine. That's all I did. And then over 14.9. right? That's going to be approximately something we plug in. All right, so we get 12, inverse sine first. 12 times sine of 30 divided by 14.9. We get 24.9. Right? That's degrees. So that goes here, 24.9 degrees. And then I don't know why I closed the calculator. We're going to go ahead and figure out 180 minus the other two angles to get my third angle, 24.9. You could do law of sines again if you wanted to. You do not have to. It's much easier just to subtract away. Right. So there is my triangle. So law of cosines, even though the formula is worse, did you see how much easier it was to work with? I guess law of sines is pretty easy too. I think I get annoyed of law of sines because of how much it comes back, but it is pretty easy. So that formula is tough, but you'll get it down over some time. All right, one more example here. An example and then an application. All right, so this is another scenario we haven't seen. I have alpha, beta, gamma. I have little a, little b, little c, and I got 5, 7, and 10. What's the difference here if you haven't pieced it together? We don't have any angles, right? We're trying to find the angles. Now, if we were only given angles, that means we can't find an exact triangle because any similar triangle of that will be the same. So angles aren't enough, but if I had all sides, I'm good. Now, I can use any part of law of cosines to get the angle. I'm going to just use the straight one, the one I memorize the most. BC cosine alpha. All right, so I'm going to plug everything in. I got 5 squared equals 7 squared plus 10 squared minus 2 times 7 times 10. And then this is the part we don't have this time. All right, so I'm going to work out these piece by piece. Okay, 7 squared is 49, 100 squared. I get 149 minus 7, 140 cosine alpha. All right, so notice there's 3 parts here. So all we have to do is get the cosine by itself. So I'm going to minus 149. So 25 minus 149 is 124. Minus 140 cosine alpha. I'm going to divide both sides by the negative 140. So I get negative 124 over 140 equals cosine alpha. So inverse cosine now of that negative 124 over 140. So we got an angle alpha to be 152 point. That is, and so something's up, something's wrong. So let's figure out where we went wrong. 14, 140 minus 2. Oh, this is a minus. There we go, we found it. Okay, so let's see. We'll redo it now. All right, the reason I knew it was wrong is 5 is the smallest side. There's no way it's 152 because that would imply that the other ones have to be bigger than 152. So that's why I knew something was up. So I'm going to go back up and I messed up a negative. So there we go. That seems more rational. 27.6. All right. And then we just have to do it again. Or no, we can use law of sines. So sine of 27.6 over 5 equals sine of beta over 7. So that means sine of beta is equal to 7 sine 27.6 over 5. So beta is inverse sine of that. Be lazy there. So beta is approximately, and we just have to plug it in, failing. There we go. I don't want it on that side. I want it on the other. I'm getting to that age. I feel like you guys watch me and you're like, come on, it's not that hard. Okay, sine of 27.6 divided by 5. So we get 40.4 degrees. Now, I don't need to do any more trig. I can just add those. So that's what, 67, 68. So that's 112, I think, degrees. If that's slightly off, forgive me. I think it's right. 67, 68. Yeah, that's right. Okay. Cool. So there's those three sides using the law of sines. Again, you'll use law of cosines. You'll use cosines, and then you'll have to use law of sines once after that, almost every time, depending on what they're asking for. All right, one more example here. It's an application. Suppose a boat leaves a port, travels 10 miles, turns 20 degrees east, and travels another 8 miles as shown in the figure. Okay, so I'm going to redraw my triangle because that one's real small and it's kind of hard to deal with. So I'm going to go ahead and straighten this up if it would. There we go. Straight down. And then there's my triangle. Okay, if this is 20 going straight up like that, right, caught in here, this has got to be 160. Let me go ahead and just do an arrow. 160 degrees. This is 8, this is 10, and they're just wanting this point C right here. Okay, so C squared equals A squared plus B squared minus 2AB cosine of gamma. So C squared, and I'm just going to plug everything in. 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of 160 degrees. So it's just a calculator problem. Most of the time, these applications are easier than the ones that aren't applications, and people just get in their head about it. All right, so 10 squared plus 8 squared minus 2 times 10 times 8 cosine 160. So I got 314.35, and I'm going to just use the calculator here. Square root of that exact same number is going to be a rough 17 point. Did they tell us to round? No, 17.7, and those are miles. So again, the problems are all very similar. It's just, can you work with the formula? I have one more application in the video after this using to find area, and we'll be done with law sines and cosines.